Hi, this is my presentation for week 4 assignment. So for the first question, we're given population mean is 150, population standard deviation is 180, and the sample size is 345. So standard deviation of the sample mean will be equals to 9.69. It measures the average variation between the sample means and the true population mean if we repeatedly took samples of size 345 from the population. It reflects the precision of the sample mean as an estimate of the population mean. The smaller the standard deviation, the more precise the estimate. For question 2, to explain the 95 confidence interval, we assume that the sample is coming from a random sampling. It's randomly drawn from the population. For numerarity, we believe that either the population disruption is normal or the sample size is large, with the sample size equals 345. The sample mean is approximately normal due to the central limit theorem. And known or approximated error is we either know the population standard deviation or use the sample standard deviation as an estimate when the sample size is large. The independent observations in the sample are independent about each other. A 95% confidence interval means that if we repeatedly sampled from the population and constructed intervals, approximately 95% of these intervals will contain the true population mean. For the last question, we're testing the claim about the population standard deviation with null hypothesis is 13. Alternative hypothesis is less than 13. The sample size here is 32, and the sample standard deviation equals 10.46. 10.4. Significance level equals 0.05. So the test statistics score that we have is equal to 19.83. The critical value is 19.45. Since 1983 is larger than 1944, we fail to reject the null hypothesis. There's not enough evidence that at significant level of 0.05 to conclude that the standard deviation is less than 13 hours. So we accept, fail to reject the null hypothesis. And here's the references for the assignment. Thank you.